In this module, we'll talk about Aviatrix features. In the previous modules, you got an introduction to CSP networking and how the various CSPs are similar but different when it comes to their networking and security services. And then you learned about why it is so important to have an architectural approach to building in the cloud when we discussed the Aviatrix multi-cloud network architecture. Now we're going to discuss at a very high level some of the key Aviatrix platform features and how we can solve networking and security challenges in the cloud. Specifically, we're going to cover some of the core platform features, transit, Ingress security, Egress security, and high-performance encryption. Let's start by introducing the Aviatrix Cloud Network Platform software. The first thing to understand about the platform is that it is not a SaaS offering or a managed service. It is something that you own when you subscribe to it from a CSP Marketplace. When we say it's yours, we mean that all the components of the platform that we'll introduce on this slide will show up in your AWS account as EC2 instances and VPCs, or in your Azure subscription as virtual machines and VNets, or in your GCP project as compute engine instances and VPCs, and so on and so forth. There are a few components that make up the platform. The first is the controller. The controller is a centralized control, automation, and management plane. It is the brains of the solution. It is a multilingual entity that provides a unified control plane, management plane, and automation plane in a single cloud or in multiple clouds. By automation plane, we mean that anything you can do from the user interface of the controller, you can also do from the Aviatrix Terraform provider, which works in all clouds. When we say that the controller is a multilingual entity, we mean that it can speak the native APIs of the CSPs. And because of these deep API level understandings, we can embrace and extend the cloud-native constructs of those CSPs, any of the ones shown on the screen, AWS, Azure, GCP, OCI, and Alibaba Cloud. We can work with those constructs and enhance them, make them better. We can orchestrate them and provide better scale. The next components of the platform are the gateways. Gateways are represented by the red circles with arrows pointing towards each other, and they represent the distributed data plane of the platform. You deploy these gateways directly from the controller, and you manage their lifecycle also from the controller, either via UI or via Terraform. You never interact directly with any gateway. That is the benefit of a centralized control, automation, and management plane. And you can get even better performance and visibility with Aviatrix gateways than you can with the CSP constructs to achieve advanced networking and security. We also have deep API level integration with third-party vendors such as Fortinet, Checkpoint, and Palo Alto Networks. With these partnerships, you can achieve service insertion and service chaining. What that means is you can deploy next-generation firewalls from these vendors directly from the Aviatrix controller. Again, from the UI as well as from Terraform. Then we have CoPilot, which is represented by this red icon that looks like a pilot hat. CoPilot is the day 2 operations component of the platform. It provides advanced multi-cloud operational visibility and troubleshooting capabilities, such as with FlowIQ and topology mapping. The operational tools provided by the CSPs don't cover the needs of enterprises, and especially the network and security operations teams of those enterprises. And we'll go into more details when we cover the operations module of this training. As we just mentioned, the components of the Aviatrix platform are the controller, CoPilot, and the gateways. Here you see a simple hub and spoke topology in AWS, where the application workloads are in the spoke VPCs, where you have Aviatrix spoke gateways. If the application in one VPC needs to talk to an application in another VPC, regardless of which account it is in, it goes from the spoke gateway to the transit gateway, and then to the spoke gateway in the other spoke VPC. And this could be a single gateway, it could be multiple gateways. If it is multiple, then the controller builds multiple IPsec tunnels to provide high availability and forwards traffic in an active-active manner. Disabling encryption is not an option here. These connections are always built over IPsec. Many enterprises have separate billing accounts or subscriptions per VPC or VNet, and that can get extremely difficult to manage on their own. It becomes difficult to apply policies to your network. However, you can onboard all of them onto the Aviatrix controller so that you can get a unified view of your environment and are able to achieve network correctness. Also, As shown here, you can connect your gateways to on-premises resources such as data centers. And just with this setup in a single region of a single cloud, you immediately get a lot of value with multi-cloud network architecture. Now, this design can be repeated in other regions of the same cloud or in other clouds altogether. It doesn't matter. The beauty of MCNA is that it can be applied to any environment in the cloud. You get the same functionality, same automation, same feature set across all clouds: AWS, Azure, GCP, OCI, and Alibaba. Cloud-native offerings are limited to 1.25 gigabits per second throughput, and that is a well-known limitation in the industry. It is simply not enough to enable highly performant applications for the enterprise. Aviatrix has a patented technology called high-performance encryption that achieves encrypted throughput upwards of 75 gigabits per second. And you can run this within a particular cloud, across clouds, or even down to on-prem. Now, to provide enhanced security postures for your organization, you can segment or isolate your traffic. You can segment it in a few different ways. One way you can do this is by network domains, which uses routing to provide isolation. Another way to provide isolation is to use microsegmentation, which provides more granular controls for distributed applications in the cloud. But regardless of the approach, you can achieve this across different clouds, which is something that no CSP can provide. Another dimension of security, for compliance reasons, is to inspect important traffic. You can send this traffic to third-party vendors that provide advanced security services, such as next-generation firewall capability. The Aviatrix platform allows you to service chain this traffic to vendors such as Palo Alto Networks, Checkpoint, and Fortinet. It is another zero-trust policy model that you'll see in many places in the Aviatrix platform. We had mentioned earlier that CoPilot is a core component of the platform. It provides enterprise-grade visibility for day 2 operations. That means empowering your operations teams with the visibility they need to manage their infrastructure. We also provide zero-trust policy-based mechanisms for users to securely access their workloads in the cloud, such as when they are on the road connecting via VPN from their laptops. For additional security, you can enable multi-factor authentication using SAML-based identity providers. And we also provide measures for securing your workloads that need to talk to the internet, whether that's inbound or Ingress, or outbound or Egress. Aviatrix is a born-in-the-cloud company. As we mentioned earlier, we embrace and extend cloud-native constructs. And because the CSPs are our partners, we integrate with many of their offerings, such as load balancers, to provide enterprise-grade networking and security. Regardless of how large your environment is or which cloud your environment is deployed in, you need only one controller for your entire environment. You don't need to deploy a controller per CSP. You also don't need to sign any licensing agreement. All you need to do to get started is subscribe to the controller offering from the relevant cloud service provider marketplace. And you can use your existing CSP credits, such as AWS Marketplace credits. So you can start simply in a metered or pay-as-you-go manner. And that's how most of our customers start. And then they sign long-term enterprise agreements for term pricing. Here's an overview of some of the top features of CoPilot. Network operations teams must have deep visibility into network activity, and native public cloud networks are opaque. Multi-cloud visibility is simply not available from any cloud provider, and it's not in their interest to provide this. Topology View provides dynamic mapping. Unlike static Visio or Lucid diagrams, most importantly, the information provided is actionable. FlowIQ makes use of about 100 NetFlow fields to provide meaningful data that can be filtered in many different ways. This, combined with additional metadata such as latency and tagging, delivers granular multi-cloud flow inspection as well as global traffic heat maps. AppIQ allows network teams to work more closely with their application teams. It provides a detailed analysis of traffic and systems that form the path between two application endpoints, including gateway performance, network latency, route table analysis, network domains, and much more. This way, just at a glance, you can determine if an application performance issue is because of the application or the network, and if in the network, then where in the network. ThreatIQ and ThreatGuard provide real-time threat intelligence and remediation. and we'll go over this in more detail in a separate section. Network Behavior Analytics provides workload and network traffic fingerprinting to create a customized network activity profile that can be used to alert against anomalous network behavior. And we'll go over this topic in a dedicated section as well. Microsegmentation empowers customers to build zero-trust environments for applications that are distributed across multiple regions or multiple clouds. New cloud resources will automatically be protected by existing security policies based on their cloud-native tags. This is another topic that we go into more detail separately. Now let's dive into some of the features Aviatrix provides, starting with transit. The transit is the most important part of any network. It is the core of the network. It is the backbone. It has to be robust. It has to be highly available, and it has to provide a variety of networking services in a secure and highly performant manner. All other features, such as service chaining and connecting to on-prem networks, they all tie back to the transit. Now, some alternatives to Aviatrix are to deploy third-party vendors for your transit network. But there are many drawbacks to this approach. Typically, these vendors are the legacy network hardware vendors who have repurposed their on-prem offerings to the cloud, which results in bloated instances. They're not able to attain encryption at throughput beyond 1.25 gigabits per second. They don't have a centralized control plane, let alone a centralized management and automation plane. And as a result, without having that agility, you're left with having to manage a lot of complexity. This is the multi-cloud network architecture again that we spoke about earlier. Notice how transit is right in the center. You have spoke VPCs where your application workloads reside, and you have transit VPCs for connecting spokes to each other. And that happens from the gateways. Since Aviatrix is a born-in-the-cloud company, our platform is optimized for the cloud. Our gateways are lightweight. For example, in AWS, you can start with a T2 micro, and their lifecycle is managed completely from the controller. Whether it's UI or Terraform, it doesn't matter. You never interact with gateways directly. Spoke gateways and transit gateways are attached via IPsec tunnels that the controller builds. The architecture allows you to extend this design to multiple clouds, such as Azure. Again, your workloads are in the spokes, and in each VNet you have Aviatrix gateways. Then you peer your clouds together with a single click in the UI. This is called transit peering. The same approach applies to GCP, or OCI, or Alibaba Cloud. It's the same architecture. For connecting to on-prem resources, such as branch offices, data centers, remote users, or the internet, that happens in the access layer of the MCNA model. You can improve your security posture by isolating and segmenting traffic based on network domains. For example, resources in the red network domain or segment can only talk to resources in other red segments by default. Likewise for the blue segment. And you can even extend these domains down to the access layer to on-prem resources. Since multi-cloud network segmentation works across all clouds, it allows enterprises to apply policies that are deterministic and consistent across all accounts, subscriptions, and projects, across all regions, and across all clouds. This is how you can enable compliance and governance on demand, and say, for example, get a risk audit done very quickly. Let's take a closer look at this example. The way to interpret this is to follow the color coding. Resources in the blue network domain or segment can only talk to resources in other blue segments by default, regardless of the account or subscription, regardless of the region, regardless of the cloud. Likewise for the green segment or network domain. Resources in this segment are isolated from resources in the blue segment. Unless you define a connection policy. A connection policy allows different network domains to communicate to each other by passing routes. Now we can get even more granular with microsegmentation. Microsegmentation allows you to define your applications in cloud-native terminology using tags and labels. It empowers you to build zero-trust environments for applications that are called app domains. These app domains are distributed across multiple regions or multiple clouds. New cloud resources will be automatically protected by existing security policies based on their cloud-native tags. Now let's talk about how Aviatrix secures Ingress traffic, which is traffic coming in from the internet. AWS has a service called Amazon Guard Duty. It is a threat detection service that continuously monitors your AWS cloud network for malicious activity and unauthorized behavior to protect AWS workloads. It uses a threat intelligence database to identify threats and alert you on them. But the problem is that it doesn't do any remediation on these threats. It doesn't take any action on them. So for all intents and purposes, it is like an intrusion detection system. Aviatrix has a solution called Guard Duty Enforcement. It takes Ingress traffic and leverages an AWS feature called Ingress routing to redirect traffic to an Aviatrix gateway. Next, because the controller has deep API level integrations with AWS, Guard Duty provides its findings to the controller. And finally, the controller will program the gateway with filtering rules or firewall rules to block traffic from bad actors or malicious IPs that Guard Duty identifies. Now let's talk about egress security, or traffic going out to the internet. And we'll start by describing the problem statement. Very often, a layer of security is applied to cloud workloads by making them private, such as by putting them in private subnets in AWS. But they still need internet access for a number of reasons. They need internet access for integrating with certain SaaS applications, such as Microsoft 365 or Salesforce, or for patching, such as doing a Windows update for your virtual desktop infrastructure, or Yum update for Amazon Linux, or apt-get update for Ubuntu, or for connecting to version control systems such as GitHub. You need to support such egress actions. You can't just stop them altogether. So what are your options? Well, you could try filtering based on the IP addresses your workloads need to access, such as Microsoft 365, but those IPs are always changing, so that's not a very scalable approach. A better approach is to use fully qualified domain names, or FQDN. What if you were to use a NAT gateway? It turns out a NAT gateway will open up all outbound traffic. That's not very secure. It makes your entire infrastructure susceptible to data exfiltration that could break your compliance model. What about a squid proxy? Well, squid proxy is very difficult to manage and has well-known scale and high availability limitations. You could use layer 7 firewalls, but those are expensive solutions, especially when you deploy them in every VPC and in a highly available manner. It becomes an overkill. So what's the right solution? The right solution is to use another zero trust feature called Aviatrix Egress FQDN filtering. With this feature, you can create and enforce egress FQDN filtering policies in a low-risk manner. You don't even need the Aviatrix multi-cloud network architecture deployed to get started. You can just launch an Aviatrix controller in any cloud and take it from there without any Aviatrix transit or spoke gateways. So there's a very easy insertion point with this solution. In fact, many of our customers use this as a direct one-to-one replacement of AWS NAT gateway. Egress FQDN filtering takes advantage of the centralized control, management, and automation plane. As with all other features, you can create these policies from the UI as well as from Terraform, and they can be applied to Aviatrix gateways in a centralized manner or in a distributed manner. In the centralized model, your egress gateways are in the transit layer, where your transit VPCs, VNets, or VCNs are. In the distributed model, your egress gateways are in the application layer, where your spoke VPCs, VNets, or VCNs are. Policies are called FQDN filters, or tags. You can create allow lists as well as deny lists. You can filter on HTTP, HTTPS, and SFTP traffic, or any other TCP or UDP traffic for that matter, and wildcards are supported. With allow lists, by default, all egress traffic is blocked except certain FQDNs whom you define in your policy. Traffic initiated from your workloads to only those domains will be allowed out on the internet. Everything else will be denied. Now let's take a moment to discuss high-performance encryption. If we take a look at this diagram, at the bottom we see an on-premises data center. This is your data center. You own it. You have total control over it. Therefore, you trust the data path there. Then, in the middle, you have the private circuit offerings from CSPs. You have Azure Express Route, AWS Direct Connect, GCP Cloud Internet Connect, or OCI Fast Connect. This is how you achieve high-speed connectivity from on-prem to the cloud. Now, regardless of what service you use, although these circuits are private or dedicated in nature, they are not encrypted. And that can be a major problem because if you are running some important workload, very often compliance will require encryption on the wire, not just at a single hop, as is the case of MACsec, but end to end encryption. And not every single workload is going to be encrypted by TLS by your application developers. Maybe they'll do it for production workloads, but not for development. And we've seen on several occasions hackers using the development environment as an attack vector to insert malware, such as ransomware, into production code. So you need to own the data path in order to encrypt it. Because if there's a breach, the CSPs will not be responsible for it. Ultimately, you, as an IT infrastructure owner, are responsible for securing your workloads. And the best approach is defense in depth. Now, CSPs have cloud native offerings to encrypt your traffic, but they are all limited to 1.25 gigabits per second. So even if you purchase a 10 gig link and you encrypt it, you'll only be able to achieve 1.25 gigabits per second throughput. That's a waste of your investment. And the reason why you get only 1.25 gigabits per second is because the CSPs don't optimize their code to take advantage of all available cores of the CPU. They only use a single core with a single tunnel. Aviatrix solution to this is high performance encryption. When you use this feature, Aviatrix will utilize all available CPU cores to build multiple tunnels between Aviatrix gateways. Within the cloud, those gateways could be transit or they could be spoke. When connecting to on-prem resources, such as data centers at the edge of your cloud network, you can also use high-speed encryption at line rate. You would connect to virtual appliances called Aviatrix Secure Edge Gateways. These used to be known as Aviatrix Cloud N appliances. Aviatrix Secure Edge Gateways can be easily deployed from the Equinix Marketplace in a zero-touch manner.